Hi everyone, today we're talking about how we can describe trends and find linear associations in scatterplots. You do not need to write down everything we'll cover in this video, but be sure to jot down important information and at least one example of each type of problem that we'll cover. Also remember that you can pause the video to jot down important notes, rewind to view information again, and fast forward if you think you got it. Be careful and make sure you don't fast forward so much that you miss out on something important. So let's start off with a review. Last time we talked about how correlation does not mean causation. So just because two variables are correlated or related to each other, it doesn't mean that one necessarily caused the other to happen. The correlation could be explained by a third variable. So we talked about the example with the firefighters. Just because you see a correlation where you see more firefighters on the scene and more property damage doesn't mean that the more firefighters you bring to help out, the more damage you're going to have at the end. It's not a cause or effect. It's important for us to review that because today we're talking about how to describe trends that you'll find on a scatter plot. So a lot of times you'll have a very accurate scatter plot, but it's how people interpret it that messes things up. So two people can see the same scatter plot like this one and walk away with different results. One person can look at it and say, oh my gosh, like we gotta stop bringing, upwards of 40 firefighters on the scene because that's causing houses to have more damage, fire damage. These more firefighters is bad. And another person can read it and say, okay, there's clearly maybe something else going on here. I don't think it's a cause and effect thing. So biggest error sometimes with mathematical data is just how people interpret it. There's that human error to it. So that's what we're going to be practicing today. So I made you a little meme. So for that scatter plot, you're not reading it and interpreting and saying, having more firefighters on the scene causes more property damage. That's not correct. What you should be reading it, interpreting it as, and you should be saying, fires that require more firefighters on the scene tend to also create greater property damage. So the key word there is tends to. So you're not saying it always does, but you're saying it also tends to have this other result. While causes is a very strong word. It's saying that if this happens, then this other result will happen. It's an if-then statement, like in science. So it's implying that it's always going to happen. Having more firefighters on the scene will always create more property damage at the end. While tends to is a more vague statement, and it just tells what you notice. Fires that require more firefighters on the scene tend to, on the whole, on the average, also create greater property damage. Because there are instances where it doesn't, right? You can have a lot of firefighters, 40-ish, that creates only this much damage, while in another scenario you have less than 30 and it creates the most amount of damage. So tends to is a very safe phrasing. Tends to. Be sure that you have those words written down in your notes. Keywords tends to, and avoid the word cause. The last thing we want to cover is the different types of associations. So we have, as you probably notice, positive and also negative correlations. So this right here, and you can make quick sketches of these in your notes, but very important to have in your notes, is a strong positive correlation. So as both of them go up on their scales, up is more towards the right for the x-axis, and up is up, more up for the y-axis. As one goes up, the other one also goes up. It's positive. While for negative, it's as one goes up, the other goes down. It's going in a downward motion. These two are both positive because they're both going in an upward motion. However, when the dots are more tightly you know, clustered together, more like a line, that's a strong positive correlation. While when they're looser, it's just moderate or a weaker positive correlation. They still make a positive correlation, but they're a little looser and they make less of a line. And then we have no correlation. They just make like a mess, just a weird cluster in the center. And then this is moderate or a weaker negative correlation. They make less of a line. This is stronger. They're grouping together more like around a line. And then sometimes we have a curvilinear relationship. So it doesn't make a straight line, but it makes a curved line. And we'll possibly go through some examples of that later. So be sure that this is in your notes, and then we'll go on and talk about examples. All right, so we'll kick it off with positive and negative linear associations first. This question is asking, what is the best description of the relationship in the scatter plot below? Is it positive linear? Is it negative linear? We don't even really need those numbers. Is it non-linear, or is there no association? So non-linear would be like your curve. And no association would be like, it's not a curve or a line, it's just going to clump there. So go ahead and pause the video and see if you can solve it on your own first. All right, in cases like this, I like to draw, a little sketch on the sides, and I create like a little funnel. So that way I can figure out what's going on, okay? And then I also like to figure out one point on each side. So if I had a point here versus a point here, okay, this would be like 100 on this end, and it would be like 100 on the other end. This number, let me make that into a coordinate plane, or a coordinate pair. So it would be 100 for the x, and it would be 100 for the y. Here, the other point that I made down here, according to this trend, would be like a 50 for the x and like a 60 for the y. Okay, so that means as x is increasing, y is also increasing. X goes from 50 to 100, y goes from 60 to 100. So they're both increasing. So that means it's positive if it's increasing for both. That's a positive linear association. Okay, so you should have chosen A, positive linear association. Negative would be like if it was going in the opposite direction, like this. This would be negative. As one was going up, the other one was going down. Non-linear would be like if it's curved in any way, and no association is just like a group of dots that make no association at all. Let's try another one. This graph shows the relationship between the age of drivers and the number of car accidents per 100 drivers in the year 2009. What is the best description? Positive linear, negative linear, non-linear, or no association? Pause the video and try it. Alright, so again, I'm going to make my sort of funnel. I can't really draw over here, but you kind of get that it follows the same trend. Okay, and I'm going to choose two different dots. I'm going to just create two dots over here. Doesn't really matter. I'm just basically seeing what's going on. So this one, the x is around 20 and the y is around 19. This dot, the x is about 16 and the y is about 24. So the x is going from 16 to 20. 16 to 20, so that's increasing. X is increasing, and the y is going from 24 to 19. Y is decreasing. When that's happening, when at least one of them is decreasing, that means that it's negative. It's a negative association, okay? So this is a negative linear association. So it's also like slope, if you want to think about it that way. It's a negative slope. So you could have used a rise that's positive and a run that's negative going to the left. It's not nonlinear because it does create somewhat of a line, and it is clearly not association as well. It's getting close to it though. It's pretty loose. Okay, so that's your positive and negative linear associations. They'll just give you a scenario here. This one, I would say, is a no association. It doesn't make any kind of line at all. It's just kind of a weird blob. I couldn't even draw a line if I wanted to. No kind of funnel that I can make. There's no association. Everything's just all over the place. Okay? All right, the next type of problem that you're going to be asked to solve are these describing trends. So you have to be careful with your language here. They want to know which statement is the best description of the association between these variables. This is average temperature of the world over time. So I can make myself a little funnel. Looks like we have X increasing because it's going from like 0 to 40. And then our Y is going from like 1 to 1.5. So also increasing. Both are increasing. So that means it's a positive linear association. Okay? So both are increasing together. So we can say as time goes on, as time goes by, as time increases, the degrees above Celsius, the degrees above 13 Celsius is also increasing because both of them are increasing. And I love how they use the word tends to, so we want to make sure we use that one as well. As time went by, the average temperature tended to increase. That's what we found. Tended to decrease would be the opposite way. And then no clear relationship would be like if it was just like a blob of points. Like I can't find a relationship at all. There's dots just everywhere. Okay? So tends to is your key words there. Go ahead and pause this video and try this one on your own. Okay, so which statement is the best description of the association between these two variables? So again, I'm going to make my funnel. This looks like it's going downwards, but I can always double check. If I had a point up here, the X is at 20-ish. And a point down here, the X would be at 100. So infant mortality is my X value. As infant mortality is increasing, then my life expectancy, my y-axis, is about 50, and this is about 13. My life expectancy is decreasing. Okay, interesting. And this is different countries. So countries with higher infant mortality rates tend to have longer life expectancy. Nope, we saw that decreasing. Countries with higher infant mortality rates increasing tended to have shorter life expectancy, decrease. That one looks like it would be correct. Yep. Okay. So yeah, that makes sense. Infant mortality is the amount of babies that don't make it past a certain age. So as that is increasing, that's not a good thing. Those countries probably have shorter life expectancies as well. They don't live to a longer age. That makes sense, right? So both are kind of medical concerns. So that makes sense. All right, so read these carefully, get your positive and your negative correct, and remember on a quiz you would definitely need those words tends to describe the trends correctly. Let me know if you have questions, and I'll see you in class.